Hi students. See, in the previous session, we discussed that how 32 bits are converted into 48 bits by using expansion box and do XOR with the K bits, and then you are going to do with the S box. Now, what happens in the S box is, see, S box is very simple. You will be having 8 blocks into each 6 bits each size, right? Now this you have to convert into 8 into 4 each. See, can you see the lines here? 6 bits. Here I got 4 bits. So how I got this is a next diagram will be giving a brief idea, like a proper idea exactly. You can understand that how we are getting this. See, this is the S box where we are going to get data which is having 48 bits converted to the 32 bits. Now, 2 bits used to select amongst the 4 substitutions. So, how should I get this is you must have must have been followed with one table, that is a S box table. What happens in this table is, now if you can see this input of 6 bits, 0, 1, 1, 0, 0, 1, 1, 0, 0. Now I am going to convert this into 4 bit now. See, last 2 bits which I have 1, 0. So what do you mean by 1, 0? That is 2, right? So go to 2. This is S box is fixed S box. You will be getting this in the, you can get this in the textbooks or else you can download it from anywhere. Now, what is 0010 medium 4 bits, 0011 is 3, right? So whatever we have 2 and 3 slot, that is 8, right? So it is nothing but 100s. Okay. So this will be the converted 6-bit format to the 4-bit format. So like this, we have to convert all 6 bits using this table, right? We must convert all 6 bits using this table. Got this? So this is what the S box will be doing, right? See, outer bits 1 and 6 will be the row bits. Inner 4 bits from 2 to 5 will be the column bits. Now, whatever you get in that slot, you have to replace that with the 4-bit format. Got this, I guess, right? So this is simple S box which we have now. Now, next one is a Mangler function. Next one is a Mangler function where we are going to discuss about the expansion and also the S box. See, Mangler function is nothing but whatever we have done in this slot, that is doing expansion, go with the XOR and S box. So these 3 slots together, we call it as a Mangler function. Okay. So expansion box, you go with the XOR operation with key, K of 48 bits and your expansion bits of 48. You will get the output as 48. Now give this 48 to S box to get 32 back. Okay. So input of expansion is 32. So this total slot of applying the content is nothing but the Mangler function. So in exam point of view, you will be getting this for sure. Define in detail about, or else explain in detail about Mangler function. So your job there is to just write about this. Clear? Now, how the key is applied now. See, always I'm saying if my block is of so and so bits, I must have same size. See here, I have 64 bits of block, means of plain text, means I should have 64 bits of key also. Now, as I am converting by using permutation choice 1, PC1, if you have seen in the diagram, you will get one idea again. So here I am getting 56 bits by eliminating all the 8-bit column. I'm just eliminating all the 8-bit column. Okay. So that I'll be getting 56 bits in my hand. Now 56 bits you just convert into 28 as 2 halves. Now you start applying with the key rotation. You start applying with the key rotation. See, what is this key rotation is nothing but every time when I am moving from round 1 to round 2, I should not have same key which I have given used for the round 1, should not be same with the round 2. So that is the reason I must go with the application of rotation. Okay. So what we are doing in this rotation is, see, round 1, 1, 2, 9, 16 must be shift one bit only, must be shift only one bit, left circular shift. Okay. So left circle, see, if my bit is like this, something like this. Okay. So my round 1 will be shifting this only once. See? My output will be like this, and somewhere as a 56th bit, I'll be getting this 1 back. Okay, so round 2 also 1 bit shift only. Round 9 also 1 bit. Round 16 also 1 bit. What about 3, 4 to 8? Next 10 to 15. So in these rounds, it will be shift with the 2 bits. Okay, it will be shift with the 2 bits. So if it is round 3, I must shift 1, 0 for sure. So my output will be starting from here. Okay, starting from here, 1, 0, 1, 0, 0, so on. Shift 1 first, next shift 0 second. Okay, so this is what we do in the each and every rounds for getting proper key generation, right? Now, see here, 64-bit data, drop with the parity, that is the last 8th bit column will be ignored, so that we get 56 bits, convert into 2 halves, I mean 28, 28. Now, shift left. Okay, if it is round 1, 1 bit shift left. Yes. Next, go with the compression box. So what happens in this compression box? We are going to convert. See, compression box input is 56 bits and output is 48 bits. Here, we are going to, on our choice, I mean the developer choice, going to ignore 8 bits, drop 8 bits, whatever the choice given by the programmer of that algorithm will be given with the 8 bits drop, so that we'll get 48 bits. Now, as we know, this 48 bits we are sending for the plain text expansion output 48 bits XOR, yes or no? So that is the reason we need to convert this 56 to 48, and combinedly we are doing one XOR over there. And next, round 2, same, shift left, shift right, shift left, and convert compression box again with round 2. If it is round 3, see, shift left for round 3 will be 2 bits. Don't forget, this is 2 bits. Only 1 to 9 will be 1 bit. Okay, 1 to 9 will be only 1 bit. Got this? Next, DES key generation steps are this. See, in the first step, what we have done? In the first step, what we have done is a 8th bit column we ignored. Second choice, we are going to eliminate 8 bits which are on the developer's choice, right? So this is what we are doing. Next, however, the left shifts, see, round number 1, 2, 9, and 16 are with ones. Okay, only 1 left shift. Remaining all to be done with 2 left shifts. Okay, so this is what is about DES key generation steps. And the permutation choice one is the first step where we have ignored 8, 16, 24, 32. See, here you don't have 8, 32, 64 and all those things. Now, decryption is a process which is of exactly reverse process of all the steps. So we'll be having a good example whenever we do in the sessions, which is not there in the syllabus. Like the example delivery is not there in the syllabus, but it's working principle you must understand as we have discussed as of now. Now the summary is just taking 30 seconds time. we will be having input of 64. Do the initial permutation only once. Now, every round we are going to do expansion XOR S box. You go with the expansion box, convert 48 bits, apply your 48-bit K here with the XOR, go with the S box for 32 bits back. Okay. So now this we are going to get, at last we are going to swap. At last we are going to swap left and right bits, go with the final permutation, output is the ciphertext. If we apply same in the reverse order, so then this will be the decryption process. See, coming to the key generation module from 64 bits, we are going to eliminate the 8th bit column, we get 56. Then we are going to generate keys by left shift concepts and PC2, apply PC2 to get compression box, okay, to get 48 bits concept, right? So this is the overall structure of your DES, and this is the overall structure of every round. See, 32, 32 expansion box, 48 bits of key, go with the S box, get 32 bits. Okay. So this is the final thing which we have as a summary. Input 64 bits, key we are going to apply with the 48 bits as a round function. Next, you will be having 64 bits output. If you have any queries regarding this, you can contact me anytime. Thank you.